Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
Hello, everybody, and welcome to the latest episode of Lunch with Tech Leaders. My name is Adam Oberhausen. I am the Vice President of Customer Solutions with Right Brain Networks, and I'm your host for today. Joining me today is software and data consultant Tom Kowalski. Say hi, Tom.
Hello.
Hey. And, of course, we've got one of my most favorite people on the planet. Tom Kowalski again. Lancelot Carlson, co-founder of HealPay. Welcome, Lance.
Thank you. Thanks for having me.
And congratulations on the birth of your twins.
Ooh, yeah, thank you. It's a lot of work.
Yeah, it's going to be, I've got a 2-year-old I'm just like, I've got a 5 and a 2-year-old and it's still a ton of work. So, man.
I might have to drop off. No.
I wouldn't be surprised in the least bit. So, yeah, this episode I think we got postponed from last month, so we're redoing it this week. Last month you guys had some things come up, and so yeah, we're just pushed it to this month. We're going to talk about the fundamental concepts of generative AI, and I think ChatGPT 3 or 3.5 dropped a little over a year and some change ago, maybe 14 months ago, and it's just like things are happening so fast, and I just feel like a lot of people haven't even caught up and don't even know some of the fundamental concepts of generative AI. So I thought it would just be good to just kind of start at the beginning and just talk about some of those core concepts of Gen AI and see where the conversation takes us. Sound good, Tom?
Yeah, I like it. Sounds good.
So I always like to start with my history lessons, as you know, Tom and Lance. And, basically core innovation of generative AI is the concept of neural networks, right? And neural networks is basically inspired way that we've tried to recreate the way the neurons behave in the human brain. And scientists back in the 40s were actually prototyping this. 1943, a guy named Warren McCulloch and Walter Pitts laid the groundwork by proposing a model that mimicked the way neurons in the brain operated. This model was known as the McCulloch-Pitts neuron, and it was a simplified version of a real neuron capable of performing basic logical functions. However, a more true conceptual leap came in 1958 with Frank Rosenblatt's invention of perceptron, which was the first model capable of learning from data. The perceptron was designed to recognize simple patterns and was a pretty revolutionary step at the time. And so it's kind of what I've got on the early days. So even though there was some excitement in the 40s and 50s around AI, once you get into the 60s and 70s, we enter a period which is known as AI winter, where we saw reduced funding and interest in AI because of the limitations of the models and of the compute power at the time. So I think, there's still definitely many scientists, I think, that were passionate about AI, but there wasn't a lot of funding in the space. In the early 80s, things began to turn on two fronts. More advances in the algorithms and more advances in the computing power. My understanding is that the introduction of the back propagation algorithm is what really allowed neural networks to adjust and improve through learning, which made them more significantly powerful. And this period also saw the rise of something called the multi-layer perceptron, which could learn and model more complex patterns than its predecessors. that takes us to the 21st century, where we get into the big data era and even greater computational resources, which set the stage for kind of, what we've seen in the last, call it 10, 15 years, where we've got deep learning with neural networks, which the term deep stands for layers. It's they basically break it up into layers that can learn from vast amounts of data. And what we've seen with these techniques is that AI has been able to master tasks such as voice recognition, image classification, and playing complex games like Go and chess at superhuman levels. So, that's my history lesson. Anything to add, Lance? I know you're a bit of a student of such things.
Do you have anything on machine learning?
I mean, I guess I was hinting around that. I think that's what we were doing in the last 10, 15 years. But yeah, fill us in on, machine learning and its role in all this.
Well, it's just it's interesting because I don't know. I don't have the history in front of me, but I know when I started to get into it, the concept of neural network was always sort of a model you go to when the problem set is harder than what you could achieve through normal linear regression or something like that, because that was really the go-to. I feel like that was what in the 80s people were like, well, our computational power is not big enough, so let's use something easier and basically achieves what we need. And so they went for, some of the simpler models to achieve what they were looking for. So I guess that's the only part I wanted to put in there as far as history goes. And the more basic machine learning tools were sort of used prior to actual usage of neural networks. Now, there's also a whole category of machine learning that uses neural networks that doesn't use generative AI, which is what we're seeing to be more effective than generative AI in doing other more specific tasks, right? So that's where a lot of the companies that are kind of specializing in AI are showing their sort of unique proposition, are the companies that are using machine learning for more specific tasks, I think, outside of GenAI, because obviously GenAI has a lot of drawbacks. It's not at least the version of the LLM version, right? It's not going for scientifically accurate, right? It's inserting noise into the machine in order to get creativity or whatever, what we know as creativity.
Mm-hmm. You're talking about the confident bullshitter?
Yes,
syndrome?
Exactly. Hallucination is a feature, right?
So that's actually a good segue to where let's talk about models, right? So, I touched on the birth of neural networks, and but a neural network and a model are not the same thing. Neural networks are models, but not all models are neural networks, which is kind of what you were just talking on, Lance.
Yes.
So, and the neural network is a subset of models, which is distinguished by their brain-inspired design and their ability to learn from data in a way that mimics human learning to some extent. So,
sorry to interrupt. I said another kind of component to this that we all have to think about is the sheer amount of data that's available and that we can store and use. A lot of the latest machine learning algorithms, I mean, they need an immense amount of data in order to come up with like statistical relevance. And it's funny, I was just reading about the Amazon situation recently where did they abandon their project? But it was the whole like checkout experience where you leave the store and it automatically checks you out. And apparently they used 1,000 mechanical Turk contractors from India in order to get that to work. So it really wasn't machine learning; it was humans. But if you look at the beginning of these, even like OpenAI and whatnot, a lot of the data is trained by contractors, human contractors to begin with. So I've heard a lot of people joke about how generative AI is just a bunch of people in the background typing things to you. really fast.
That's why it takes so long sometimes.
I mean, it's not far off from the training perspective. At least there were humans that were an immense amount of humans that were there helping validate, right?
Yeah. You have to share me that article about the Amazon stores where you could just go in and you basically go in and you just put all the food in your grocery cart and you walk out, right?
Yes.
And you're saying it was just like an outsourced shop was like monitoring the cameras and making sure that things were actually getting charged correctly?
Yes.
Interesting. So that's not typically how a model should work. But when you think of a model in these terms that we're talking about, this term model, we're essentially giving a recipe to the computer, the program. The computer turns its ingredients, which the ingredients we'll call the data, into a meal. And the meal is your predictions, decisions, or new creations. So that's kind of like, just a little metaphor that I like to use when I try to explain things to people outside my field, and how these things work. These things can get pretty abstract pretty quick. I don't know a ton about algorithms or models. And so to me, it's fascinating. I don't know how much I want to learn. I think I've heard some people say that LLMs are not fun for engineers because you can't get in there and you can't get under the hood and tinker with it like as much like you can with other pieces of tech. But that really doesn't bother me. I don't really need to know how the black box works. But
when we say model, are we talking about before or after it's trained, or is it both? Because I hear it thrown around, and it kind of confuses me sometimes. Can this model be trained, or was this already trained on data, or is there a different nomenclature used for that, like before it's trained or after?
Lance, can you take that question? I think you'd be better suited to answer that.
Like an algorithm, right? Before it's trained, and then now it's a model, right? Or I don't know. I just kind of hear it thrown around, and I was just kind of confused. Is this what they developed, right, and then trained it, and now it is X model trained on whatever data, or is it like after it's trained, now this is the model?
From a consumer using AI perspective, I think model should be really the after training thing, right? Because you're using this model that someone spent $2 million throwing a bunch of graphics card at to generate the model for you, and then we are just consuming that version of it. So from the perspective of most people, I think the model is really just the thing that was trained after the fact.
Yeah, I feel like that's what you hear more. But
yes.
Then you hear like talking about, training this model. And it's like, well, wait, is it, before or after? So
we're gonna talk through some of the more popular models. I was planning on doing that later. And that might kind of put some insight onto that question, Tom. It's a good question though, because I don't know. That leads us to foundation models, right? I guess that is right. That's a good segue to your question. Like, so, when we've talked about neural networks, what they are, when you hear this term foundation model, which is a term that was coined and popularized by the Stanford Institute for Human-Centered Artificial Intelligence. I'm always fascinated where these terms come from. So a foundation model is basically an AI model that's trained on a vast array of information from usually across the internet. They require a huge investment to train, sometimes upwards of hundreds of millions of dollars due to their extensive data and computing power needed. However, once they're developed, they can be adapted for specific tasks, usually at a fraction of the cost. So these are, when we're talking about foundation models, we're talking about ChatGPT, we're talking about Gemini, we're talking about Claude 3. The original innovations in this space were Google's BERT, B-E-R-T, and OpenAI's GPT series. And over time, their scope has changed to now there's these multimodal foundation models. And a multimodal model can basically just do more than text. It can generate images. It can generate music. It can control robots. I mostly use ChatGPT, and so it used to, I think it's considered multimodal at this point. Is that be correct, Lance? because you can do, I don't know if you have to like run DALL-E separately from your text prompts. I think you can just use it all in one now. I know Gemini is multimodal, but anyways, that's kind of the concept of the foundation model, and that's where we saw this new era of consumer-facing AI, where consumers can interact with AIs. Where before I think most machine learning and AI stuff was like algorithms and behind the scenes that people weren't really interacting with much. You would get, your recommended things to purchase when you went to your cart. I'm sure there's algorithms, on your feed for your social media feeds, those algorithms that kind of learning what you like and interact with and feeding you more stuff to get you to engage. But I believe these foundation models are the first time you really like see people interacting directly with an AI, which I think is pretty cool.
Yeah, if you think about the way these sort of clustering algos work, if they don't have any context about what something sort of looks like, it's hard to describe it in text. I know it's kind of strange to think about, but 3.5, I believe, was text trained only. I don't know if it was GPT-5. I don't know if it was actually multimodal at that point. I know GPT-4 was definitely multimodal, and they started incorporating a lot of the, image and visual stuff into it. And so now it, understands better contextually what it's talking about from a visual perspective. I think that any model that gets closer to having a cluster representation closer to what humans experience is going to feel smarter to us, if that makes sense.
Okay. And how do they do all these? How do they create these foundation models? They did it through what is known as transformer architecture, which is our next piece, next chapter in this conversation. And I wanted to touch on the transformer architecture. It was introduced in a landmark paper called Attention is All You Need by Vaswani et al. In 2017. And it has revolutionized the field of natural language processing. And it is pretty much the backbone of every foundation model that I'm aware of. I'm not sure. I haven't looked at every foundation model, but everyone I've used and seen is built on some variation of a transformer architecture. Yeah.
And it was like a Google team, right?
Yeah, that was a Google team. And then, so that's all interesting how, Google was way out in front of the pack on all this stuff, but OpenAI kind of and other players in the space really seized on the opportunity to make the transformer architecture and, make it accessible to consumers. I'm not sure I don't know. I'm not sure if Google will ever catch up or dominate the space. They seem to fumble every time they try to do something big, but I think it's an interesting time to watch these players. And you saw Stability AI is, I think, collapsed recently. They had several $1 billion valuation. Now they're worth nothing, which is just crazy.
I do think that these players are going to start consolidating. Right now, I'm seeing 3 major models. You have Claude, you have Google, and you have OpenAI. Mm-hmm. And I think the other one, Stability was a pretty big one, and now that that's gone, those are the 3 major ones. So, luckily for Google, they have a lot of resources behind them. OpenAI has the same thing. Claude, I don't know. The interesting thing is that their latest release a lot of people seem to say that it's performing better than GPT-4 at the moment. So from a purely consumers get their hands on a model perspective, it seems to be what people are liking the most at the moment, actually. GPT-4...
It's a year old at this point.
Yeah. Maybe people are just getting bored of GPT-4 as far as... because it hasn't maybe necessarily changed, or maybe it hasn't changed, but the people are perceiving that it's getting worse or whatever it is. I do like to think that these models, people get used to them, and that's sort of why they start to think that they degrade.
they can't really change the model. It's more of, right, like how they like pre-prompt it and things like that.
Yeah.
They're kind of tweaking and changing behind the scenes that, kind of affect what everyone else is seeing.
What's interesting about Claude is that Claude has a really nice user interface for copying and pasting tons of content into it. And so you get access to their really big context window latest models if you pay the $20 a month, and you paste all of your information into Claude directly. So I think that people are, especially people that are coding with like their entire code base, like it because they just, concatenate all their files and copy and paste their entire code base in there and start asking questions about it. Not to say that that's pretty easy to do in GPT-4 and ChatGPT. You just do the same thing, but upload the file. But people are a little bit, it seems like ChatGPT itself is not using their longer context model inside of ChatGPT for the most part.
Mm-hmm.
And there is some sort of recursive summarization going on. So you do maybe lose some of that context, but there's also some RAG going on. I think that's for another episode, but RAG essentially is probably when you upload a file, it's probably splitting it up into chunks and then using RAG to find the most relevant bits and then probably recursively summarizing over that and then giving you an answer. It's my guess, but most people are feeling like, or at least I feel like, ChatGPT is not using their biggest context window to think about what you're telling it, and that might account for some of the differences between what people experience with Claude and ChatGPT.
Yeah, I've heard really, really good things about the latest Claude. People that had been loyal to ChatGPT are switching to Claude because it seems to be just a level of sophistication better. And maybe it is just that UI piece, Lance, that the UI is a big part of it. How you actually interact with a tool and its ability to make your workflow more efficient could be what's giving them an edge right now. I haven't seen it myself. So all my stuff is anecdotal, but the people I've talked to that I trust, it seems like Claude is the best in class at the moment. But we'll see ChatGPT 5 or 4.5 is going to drop here, and the race will continue, right?
Q-Star?
Yeah, Q-Star. So before we had this transformer model, circling back to the transformer, they were using models that were known as recurrent neural networks and long-term, short-term LSTM networks. These were the go-to models for processing sequential data. However, these models basically process things step by step, which is slower and less effective at capturing long-range dependencies within the data. So the transformer model addressed these limitations with the previous models by enabling parallel processing of sequence data and capturing long-distance interactions more effectively. So what does that mean? I don't know, but we're going to break it down because it's like you read about these things and it's all a bunch of, I don't know, mathematical jargon. So wanted to dive into the mechanics of the transformer architecture and what that means. So when you break down the transformer architecture, there are four components. You've got the self-attention mechanism, which is the heart of the transformer. It allows the model to weigh the importance of each word in a sentence in relation to every other word. So when you consider the word bank in a sentence, I went to the bank to fish. It can determine if bank is more related to a place where the money is kept or the side of a river. So for each word in a sentence, the algorithm calculates a set of scores that represent how much focus to put on that part of the sentence. The higher the score, the more attention. The scores are used to create a weighted average of the words representations, giving more importance to the relevant ones. So it basically looks at the whole sentence and figures out what's the important words, what's are not. Next piece of the transformer architecture is the positional encoding. This ensures that the model doesn't lose track of the order of the words. Since Transformer treats each word independently, it needs a way to remember that John loves Mary is different from Mary loves John. Okay, and then the next piece is what we call layered structure, where the Transformer architecture is made up of these encoders and decoders that are stacked on top of each other. Each layer processes the input data in two main steps: attention, where it looks at the other words, and then a series of operations to refine the understanding, like correcting grammar or clarifying meaning. So that's a little confusing. Simplified even further. The encoders process the input text, and they improve the representation of each word by considering its context. Encoders, stated differently, calculate the relationship with the other words. The decoders, in tasks requiring outputs like translation, the decoders use the encoder's output to generate and predict the next word. It all seems like magic. It is abstract to even understand.
So is this is like the inference, right, versus the training, or is it this transformer architecture used in both?
That I don't know.
Okay.
Yeah. Lastly, we've got the feed-forward neural networks. So after the attention mechanism has determined which parts of the input to focus on, a small neural network is applied to each position independently and identically. This helps to further refine and interpret relationships in context established by the attention mechanism. It's basically polishing and refining the word's meaning in the context of the sentence. So,
yeah,
I guess if we were to kind of recap all that, a transformer reads in a sentence, decides which words are important to understanding each other word. It remembers the orders of the words, and then incrementally refines its understanding of the sentence through layers of processing. Each step of the way, it adjusts its interpretation to ensure it captures the meaning as accurately as possible. So I can't imagine how an algorithm does this or what the math behind that, but that's essentially what these transformer models do. And I still don't know, I don't know, I'm still really curious, Tom, about the question you posed earlier, is like, where is the line drawn between this is the algorithm versus this is the model? Like, yeah, I don't know.
Yeah. What you just described, right? It kind of makes sense, right? And it kind of takes away the magic of it. You type a question in here, it's the answer now, relatively fast, right? It seems fast to us. And, but when you describe it right there, it's just a big old word calculator. It's like, okay, that's what it's doing. All right.
I've heard a lot of people say, well, these LLMs just guess the next word that they're going to, and it's true. They are trained on vast amounts of data, and they're able to predict what the next logical word would be. And then I'm wondering how that is different than my ability as a human to talk. Like, I feel like I've just been observing and listening to people talk my whole life. And so I really don't know anything about brain or how the brain works, but it seems like I'm just spouting out the next logical word.
You're just a big word calculator yourself.
Yeah. I don't know.
What's interesting is that, word processing and outputting is it's just one skill, right? So, and humans don't necessarily have, there's a bunch of components to that. First of all, some people think in words and other people don't, which is kind of strange. But to me, because I do think in words and other people don't, so I have a bias. But just your range of experiences. If you kind of map it to, not your range of experiences, but there's also other creatures on this planet that have brains and feed in input and do output, but they can't speak in text or words. So, we aren't obviously just word processors. There's a lot of other things going on, a lot more signals going on than just that. But, as far as what we know to be someone who is, intellectual and intelligent, in our society might just be what these things are, because text is like the biggest, where we reference a lot of the things that we understand. Text, and then their numbers representing that text, right? I mean, people just think that text is text, and it can't possibly be that, intelligent or interesting, but it obviously is, because when you train it with a bunch of GPUs and you put a bunch of you get a bunch of weights back, and then you chat with it, it is getting the standard deviation or whatever, probably not the most accurate term for it, but the statistically most relevant thing that should be presented to you in text format for that particular context.
Yeah. It's interesting what you say about how people don't think in words or text. I know, like, other mammals, like dogs, for example, their brains work in visual memory. So, like, a dog doesn't remember, a dog doesn't have an inner monologue that says, I don't want to go outside, it's raining. A dog has a visualization of, like, they'll visualize, like, well, last time when I went out in these conditions, I got wet. And,
right.
Which I don't know how they figured this stuff out, of course, but it just is really interesting to think about these other mammals and other intelligent species that don't have the ability to speak in the way that their brains work through visualization.
And even other humans, right? In different languages, I've heard, right? If you, especially like Chinese, right? It's like a completely different, way that the structure of the words and the grammar of the sentence is formed, and that kind of shapes how you think about things, if you're using that, right, as your inner monologue and how you're thinking with words. That's interesting. It's also interesting too that you say, like, okay, this is what we're using, but what's more efficient for the computer to communicate, right? It probably isn't English, so yeah, it's interesting.
So, yeah, I think, Lance, you might be the closest to this, but is there anything competing with the transformer architecture? I saw something about, like, Mamba architecture, but that seems like it was a little too much hype, or maybe it was too closely related to transformer to be considered a contender. But I mean, do you think the transformer architecture is kind of the de facto way to develop a foundation model?
Honestly, I haven't been following the newer trends on that, on architecture, but more modern things. It does seem like people are still trying to just make these models bigger and see what happens. At least from my perspective, when I'm looking at the open source models, I think the open source models are trying to catch up to GPT-4 right now. So from someone who is consuming these models right now, it just feels like there's the bigger ones, that the commercial ones are sort of stagnant because they haven't released anything new in a while, and the open source ones are just trying to catch up. But I haven't seen anything that I'm really excited about from like Transformers is the new architecture kind of thing. I don't think Transformers are the end all be all for AGI, for example, right? It's going to be a lot of different things, but yeah, I personally haven't seen anything new right now, but I haven't been looking, so.
I imagine the AI will develop its own model that beats the Transformer. Possibly. Okay, so I wanted to touch base on some interesting models that are out there that, you may have heard of, and kind of give a quick summary of what they are, what they do. One that I think is real interesting. I think Lance, you maybe even introduced me to this one. It's something called generative adversarial networks. And so these are just some interesting models that they use for training AI solutions, machine learning solutions. And the way the generative adversarial network works is, think of it as a contest between two artists, where one tries to create convincing art, we'll call that the generator, and the other judges whether the art is real or fake, the discriminator. So over time, the creator gets better at making realistic art thanks to the feedback from the judge. So this model is good for creating realistic images, artwork, enhancing photos. GANs are especially popular in the visual arts for generating lifelike images.
So it's basically like, here's one I generated, here's a real one, kind of scores them, and then it's like, no, you didn't eat this one. It goes back and tries again.
Mm-hmm.
All right.
Or you can use your mechanical Turks.
There you go.
Next up, we got variational autoencoders, VAEs. Imagine trying to describe a complex image with a simpler sketch that captures its essence. So VAEs learn to compress data like images into compact representation and then recreate the original data from this compressed form. It's like summarizing a story and then retelling it with some added imagination. So this approach is good for generating new images, music, or text that resembles the original data. VAEs are useful for tasks that require a blend of accuracy and creativity, such as designing new objects or characters. We touched on the transformer model. We talked about that extensively, so we'll go back into that. Then we've got autoregressive models. How this works is, imagine drawing a picture 1 pixel at a time, where each new pixel is chosen based on the colors and position of the pixels you've already drawn. These models generate data like images in sequence, predicting each piece based on the ones before it. Which this one really is interesting to me. I'd like to learn more about it, but it's good for generating detailed images where precision and control over each element are important. They're great for creating complex images pixel by pixel. Then we've got diffusion models, which of course I've heard stable diffusion. I don't know if they're using the diffusion model. It would make sense if they were. But with diffusion models, you basically start with a random pattern of noise and gradually shape it into a recognizable image, kind of like you're sculpting a block of marble into something. So these models transform randomness into structured data through a process that slowly adds details and coherence. These are good for generating high-quality images, audio, and other types of data where fidelity and detail are crucial. And last on my list of models is the flow-based model, where in this model, imagine you're molding clay and you can precisely control and reverse each step of the shaping process. So the flow-based models transform data into a simple form and back again, learning the exact process of how data can be deconstructed and reconstructed. So this is good for tasks that require both generation of new data and understanding the probability of specific data points. Good for scientific simulations, where understanding the data distribution is important.
So when we say like a model or interface is multimodal, right? It's kind of like picking which one of these to use based on the input. Is that like a way to think about it? Or
I'd say it has. I think so. I mean, that's a logical assumption from my perspective, because I can't imagine that if I tell ChatGPT to generate an image, it's not going to use the same API endpoint for getting me a text response. So the whole image generation must be different. I'd be curious to know if for DALL-E or if these image generators, like, I just rattled off like 3 or 4 models that talked about this is good for images. So like, does the prompt you give it, could it actually build an image using a different model based on what I'm asking it to generate? Like, there's so many interesting things that happen under the hood there. So, that's like our 101, back to the basics of Gen AI. Any other topics you guys want to explore or discuss before we call it a show here?
I was just going to say maybe the difference between like, what would you call it, from a basic, the description of the, machine learning, and I don't know if we were trying to go over a very basic machine learning things or just Gen AI specifically, but both topics get really deep. Because I was just going to say, there's a difference between when you're feeding a machine learning model numbers, or if you're doing categorization analysis. So I don't know which direction you want to go, but we can talk about very basic machine learning things, or we could talk about generative AI specifically.
You talking about right now or next episode?
Next episode, whenever, well, I just want to make sure I'm on right, category of topic. Haha.
Yeah. I think it's just the tip of the iceberg with this stuff, so we can go anywhere we want. But yeah, maybe talking about the fundamentals of machine learning would be a good thing to dive into, because Gen AI is built around those concepts, right?
Yeah,
yep, fundamentally.
And I think even though things are moving really fast, I think it might be nice to kind of talk about where we are and like the pros and cons of the different ones, like right now, right? Like the speed and cost, and what applications each models are good for, even like applied versus like theoretical. We're talking about stuff.
Yeah, kind of compare at least ChatGPT and Claude and Gemini. The three of us spend some time with each product and come in here and debate which one's the best.
I like it.
Yeah, I know, because I do a lot with Amazon, right? And they have the Bedrock as kind of like their entry point to use a lot of different models, and there's a lot of options. So it's like, which one do I choose for which application, and what makes sense for what I'm doing. So yeah,
I'm currently paying for ChatGPT and Claude. My company pays for Gemini, so I have access to all three. But I've found myself mostly using ChatGPT. But I could probably give you, if we make it into a competition where we get to debate about this, I will probably spend more time trying to evaluate more specifically what each of the models are better at, and give me some thoughts about what I should stress test it on.
Yeah, there's a lot of factors, right? Do you need it fast, right? Are you doing a whole bunch? Right, you put it into a game to do dialogue. You don't want to pay that much, right? If you're doing billions of requests.
I mean, I mostly use it for coding, and I've been busy with that. So I think I haven't necessarily stress test Claude in that perspective. I'm just more used to OpenAI's version of stuff. So I think that the differences between them are marginal, but we can talk about that maybe in another episode.
Yeah, I'm like, I have full intentions of trying these other products, but you just get used to a product, and it's like, I don't want to learn how to tame another AI. I've got my ChatGPT dialed in, so. But I'm probably pleasantly surprised by doing a little look at some other products and see if they are better in some other areas. So, yeah. On that note, I'd like to take the opportunity to thank our co-hosts and our listeners for tuning in to today's episode of Lunch with Tech Leaders. We hope you found the conversation informative and valuable. We'd love to have you join us again for our next episode, where we're going to discuss a topic that is yet to be announced. We've got some juggling of episodes happening, but we're definitely going to be talking more about serverless later in the month, and we've got some other episodes we're trying to fill in the gaps for next week and the following week. So stay tuned. Appreciate everyone joining today. Great conversation, and hope everyone has a great rest of their week, and take care.
You too. Thank you.
See you later.
Bye.